Question 3. The diagram below shows the approximate orbit of the dwarf planet Eris around the Sun. Which of the following statements is false? Eris moves fastest at point D. Eris moves at the same speed at points A and C. Eris moves in an ellipse with the Sun at one focus. The potential energy of Eris changes during the orbit. Okay, so let's work through these point by point. First, Eris moves fastest at point D. So to investigate this one, we'll consider two sections of the orbit. So first, let's consider this section here. From this point to this point, that sweeps this arc. We'll call that distance S1 and area A. And we'll say the time taken to sweep out S1 by X, Eris, is little t. Now, let's also consider this arc. Apologies, my lines aren't very straight. Which goes from this point here to this point here. This arc, and let's call that S2. And we'll say that also has area A. Now, it's clear from the diagram that S1 is much greater than S2. We also know from Kepler's second law that if these two areas swept are the same, which they are, then the time taken for the planet to sweep out this section of the orbit is also the same. However, because S1 is greater than S2, and because speed equals distance over time, we can see that the velocity of the planet at B in the orbit is greater than the velocity D. So hopefully that's clear. Kepler's second law says that for these two equal areas, the time taken for the planet to do each arc, S1 and S2, is the same, it's t. We can see by the diagram that S1 is much greater than S2, and therefore as speed equals distance over time, as time is fixed, the velocity at B must be greater than the velocity at D. And that means that actually the fastest point, or rather, because we know the velocity at B is greater than the velocity at D, the statement A must be false. Next, Eris moves at the same speed at points A and C. Hopefully that should be clear that that indeed is true because of the symmetry of the system. So that's true. Next, Eris moves in an ellipse with the Sun at one focus. Should also be clear from Kepler's first law that this is also true. So Kepler's first law stating that in a system such as this, the Sun is one of the two foci of an ellipse. Next, the potential energy of Eris changes during the orbit. So similar to a lot of systems in physics, what we have here is basically a constant energy conversion between kinetic energy or movement energy and the potential energy. And as the planet moves around in its orbit, it should be obvious that the potential energy is changing because effectively its distance from the Sun is changing. But also we actually showed when we were answering the first part A that the kinetic energy does indeed change as well, which means the potential energy must therefore change as well. So therefore point D is true.